Hi everyone, welcome back to the channel. In this video, we're going to be looking at another example of how to find the Laplace transform of the Heaviside step function. So here's the example we've got. We have a discontinuous function where it is either t squared or 3 depending on what's happening with t. So let us first convert this into the Heaviside step function. So we've got f of t is going to be equal to t squared u of t minus 0 minus u t minus 2 plus 3 at u of t minus 2 because there is no upper limit for this. And now I'm going to multiply out. So the first term is just going to be u t squared because this first term becomes u of t, which in fact just falls away. Then it's going to be minus t squared u of t minus 2 plus 3 u of t minus 2. And this is our Heaviside step function now for f of t. And we're going to be finding the transform of this function. And before we continue, let's write down the two formula we're going to be using. So the first is going to be the transform of the step function u of t minus a. And that is 1 over s times e to the minus as. And the second one, which is your second shifting theorem, I'm going to use the letter g of t minus a so that we don't confuse this function with f of t. And that's going to be equal minus as times the transform of g of t. Now, if we look at our f of t and we compare it to the two formulae we have, you'll see when you take the transform of f of t, your first term is going to be fine because that you can just read off your table. The second term is going to be a bit of a problem because it's not in the form as either one of these. Your third term will be fine because it is just going to be this first formula you will apply. So let's take the second term, this middle term. Let's take this one and work on him before we put everything together. 4 t squared times u of t minus 2. And what we want to do is we want to change the form of this function into the form inside of this bracket. Okay, so you want to have a t minus 2 as part of the t squared. So what I'm going to do is I'm going to say that is the same as, I'm going to introduce a 2. I'm going to do that. Right? So what I've done is I've subtracted 2 and added 2. So I don't change the actual value of that function. All I'm doing is changing the form of it. Okay, and I've kept the squared just as you have t squared here. So if I expand this now, I'm going to get t minus 2 squared, t minus 2 plus 4. And all of this is going to be multiplied by the step function. And if I now multiply this out, you'll see I'll have everything in the form of the second shifting function. And then plus 4 u of t minus 2. Okay, so you'll see here, look at the first term. You've got t minus 2 and you've got t minus 2. T minus 2 in the second term, t minus 2. And the third term is just going to be the first formula. So let's take the transform of this t squared u of t minus 2 because then we can just substitute everything back into the original equation. So I'm going to take the transform of t squared u of t minus 2, and we've worked out that it's going to be the same as this function here, right? So it will be the transform of t minus 2 squared u of t minus 2 plus 4 times the transform of t minus 2 u of t minus 2 plus 4 times the transform of u of t minus 2. So let's look at the first term. So if I take the transform of that, this is the same form as your shift function, the second shifting theorem. So we'll have, that is going to be equal to e to the minus 2s times the transform of the function without the shift. So the shift here is going to be 2, so that minus 2, if you were to cover it up, what do you have left? You've got t squared left, plus 4 times e to the minus 2s times the transform of your function without the shift. So if you cover up the minus 2, it's just going to be the t, plus 4 times, here it is the first theorem, so it's going to be 1 over s times e to the minus 2s. So then, if I simplify all of this and find the transforms, the transform of t squared times u of t minus 2 is going to be 2 over s cubed plus 4e to the minus 2s. The transform of t is just going to be s squared. So I'll put that over s squared plus 4 over s e to the minus 2s, right? So this is going to be the transform of your middle term. So if I now go back, let's write out what we found f of t to be. F of t is t squared minus t squared u of t minus 2 plus 3 of u t minus 2. If I now take the transform of both sides, that's going to be equal to, the transform of t squared is going to be 2 over s cubed. We've just worked out what the transform of the middle term is going to be, so that, let's put that in. I'm going to write it out like this because this is the common factor. So 2 over s cubed, 4 over s squared, 4 over s. And then the transform of the last term, that's fairly straightforward because that's just your first formula. And that is your transform. What you can do is you can simplify things, because if you'll see here, you've got 4 over s and you've got 3 over s, and that's going to simplify out. So you can write it as s cubed minus 2 over s cubed e to the minus 2s, 4, that must be minus 4 over s squared e to the minus 2s, and that is going to be the last term minus 1 over s e to the minus 2s. So there you have it. There is your Laplace transform of your function f of t. I hope that video was helpful to you. Please leave a comment below if it was. If there's anything else you'd like to see, please let me know. I'll see you next time. Bye.